Today, we're talking about TSL inside of Three.js. TSL is an acronym, stands for Three Shading Language. And it's a new component of Three.js wherein you can write your shaders right in the JavaScript. And it's compiled as WGSL. That's the shading language for WebGPU. I've created a course, The Basics of Three.js. Check it out. Here's where we're starting with this basic template, which you can find on GitHub, link in the description. Here's how it's different from the template we've been using in all of my lessons up to this point. We have these WebGPU and TSL imports now, in addition to the three and the add-ons imports. So our code is almost the same. You can see here's the original template that works with WebGL, and here's the WebGPU template. It's only a little bit different. What's different? Instead of using the WebGL renderer, we'll use the WebGPU renderer. Also, you have to tell it to have background color. The material we'll use, mesh standard node material, instead of just a standard material or whatever. And we're calling this render async method. We're going to go over all this stuff. I've been messing around with TSL, and it's pretty exciting. There's two things. It's exciting, and it, for me, is a steep learning curve. There are not so many resources out there. There's a great one from Nick Lever, or I'm not sure if I'm saying his name right. Wonderful program on his website, nicklever.com. I highly recommend that. Also, the documentation on the Three.js website is good. Besides that, it's just kind of like scavenging and scrounging around. Oh, of course, Bruno Simon has some wonderful YouTube shorts that show WebGPU in action with Three.js. It's really great. All right, so let's dive in. Starting from our basic template, let's import this position world from the TSL, and right away I'm gonna say material.color node equals this position world and see what happens. So look at that. Now the shading reflects a value. It's a vec3 world position. Besides the position, let's do it this way. We could also mess around with the normal nodes, like those, the normal, local, world, and worldview. Let's see what normal local looks like. It looks like kind of like a normal material. However, the normal material is constantly updated because it's the view, normal view. Let's have a look at that. Yeah, that looks like a normal material, right? And lastly, the normal world. But that's not the last one. There's actually more, but that's the last one we'll look at the moment. Also cool. Besides position and normal, there are nodes for tangent, bitangent, camera, model, a bunch of other nodes. I'm curious what this one does. It's called reflect view. Let's see what that looks like. I have no idea what this is going to look like. Wow. It looks really interesting. If I comment that out, we just get the basic material again. This is baby steps into the world of TSL. Are just our first steps. The next step would be to actually build out a shader. And there are tools for you to kind of play with that too. On the Three.js website, if you go into examples and type in TSL, you'll see a compiler in there. Here, that's a TSL editor. Is that the compiler? No. This is showing you, here's the TSL that you wrote, and here's what the Weasel code looks like. WGSL code looks like. Let me find the compiler for WebGPU. Here it is. So you can enter your GLSL code here for your shader. And then out here, it'll spit out the equivalent TSL. Again, that's here, the WebGPU TSL compiler. transpiler, excuse me. What are some of the things you can do to play around with this? Try out different nodes, see what looks good. Like, for example, camera position. Is that what it is? Hold on. I'm checking the docs. No, there's camera near, far, camera view matrix, world matrix, camera position. Let's do camera position, see how that looks. Where's my node? Here it is. And as I change the camera position, the material changes color. I think that's pretty cool. Well, I wonder how this would look with multiple objects. Let's see if I said function get torus knot like this. And then instead of that, say return knot. Whoops. Now I've got that. Format it real quick. And create a little for loop here. Const num knots equals 10. Not num cots, num knots. And say for I, knot equals get torus knot. I want this position code to be up in the thing, and then scene.add knot. Here, I'm going to add this to my function here. So I randomize the position. Let's see how that looks. It doesn't look good. All right, check console. Knot is not defined. Oh, here. Let's move this code up to the get torus knot method and say, I like that too, randomizing the rotation. X, Y, and Z. Thank you very much, Copilot. No, I'm not going to affect the scale, but I am going to say not.userdata.speed.update, please, update. Or just, I like it doing it this way too. Now I get an update method. Update is a function or an arrow function. You know, you can do an arrow function. I don't know why Copilot is not reading my mind today. Add those. One more curly brace, format it. Yeah, and now we can call all of those by looping over them. Woo. Let's see how that looks when you move around. Isn't that cool? Okay, but I want to do position world again and just show how that looks with a number of knots up here. I also want to shrink those down a little bit. Here, let's say const size is equal to 0.5. And now I can say size and size times. The reason I'm modifying two properties of this torus knot geometry constructor is that one of them is kind of like the overall size, and the other one is the tube diameter. I think that's what it is. So if I save that, they'll just all be smaller, and let's make a bunch more of them. How cool is that? Right? And you can animate those or animate the group. Let's animate the group real quick here. Const scene group is equal to a new 3.group. Scene.add scene group, but I want to give it an update method. Scene group dot user data is equal to, and put an update method in here. Yeah, that's what I want, except I only want to rotate the Y. And make it a little bit slower. And now I can call that in my animate method, scene group, dot user data dot update. One last thing I wanted to do. Oh yeah, if I call it right now, there's no change. Also, I want to reduce that radius. Let's call this radius. It's not really a radius, but I'm going to reduce it anyway to 6 so they fit in the view. Const radius And now, doom, doom, doom. Oh no, that's too many. I just need doom, 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 radius, and minus radius times 0.5. So now we have a reduced, oh, it's very crowded now. Let's reduce this. Oh, that's better. If we change this part here, where I'm adding the knots to the scene, instead add them to the scene group, now we'll get that nice, oh, it's way too fast. That nice rotation. Here we go. That's 5 times slower. That's good. If you choose a different node to assign to the color node instead of position world, how about position view? I think they'll shift colors as they animate. And it's not that great, actually. Never mind that. What about position local, you say? Yeah. A little dark, so you can multiply by a number to increase the brightness. Mul 2.0. Or make it 5.0. They're getting brighter. 50.0. Oh, look at that. Not really great, but let's do position world. Okay, that's totally blown out. But sort of interesting. That's also too blown out. Yeah. That concludes my monkeying around with TSL. I use the WebGL renderer, call render async, and use the node materials, and then just monkey around with different built-in properties. What do we call these? Attributes. I don't know. It's still pretty new, so this is just poking around and having fun. It's possible the API will change. It's changing all the time, I think. Hope this helps. Thanks for coming by, and I'll see you in the next one.